This video gives an example of how we use probability and normal distribution to make policy recommendation. So an example we are going to go over is the rainfall and crop choice in Burkina Faso. Suppose you are an NGO advising rural farmers in Africa which crops to plant. You advise the government of Burkina Faso. We assume that amount of rainfall in the is normally distributed with mean of 600 milliliter and a standard deviation of 50 milliliter. There are two crops that the farmers consider planting. Wheat is going to fail if there is more than 500 milliliter of rain. Cotton requires between 500 and 600 milliliter of rain to succeed. So to advise the government what to do, we need to find out what is the probability that each crop succeeds in Burkina Faso. So the different steps that to go over this type of problem is first, you want to identify the mean and the standard deviation sigma of the distribution. Draw the distribution, shade the area of interest. 3. Identify how many standard deviations away from the mean each value is. And 4. Use a normal table to calculate probability. So you can pause the video, think about it for a moment. So now how can we approach it with, let's say, what is the probability that wheat is going to succeed in Burkina Faso? The first step is identify the mean and the standard deviation. The mean in this case is 600 milliliter, which was stated in the problem. Standard deviation is 50. So wheat fails if there is more than 500 milliliter of rain. So what is the probability that wheat succeeds? It's basically asking the probability that the amount of rain is gonna less than 500 milliliter. So the distribution here, we are drawing the distribution of rainfall. And if it's less than 500 milliliter, wheat is going to succeed. So now we're going to find out what is its probability, or the area on the left of 500 milliliter. So that was step 2 when we shade and label the area that we need to find, and we need to find out again what is this area on the left of 500. And now step 3 is we identified the standard deviation. In other words, we are going to ask 500 milliliter is how many standard deviations away from the mean with a mean of 600 milliliter. So let's find out. So 600 is how many standard deviations away from the mean? Is 0 because 600 is the mean. 550 is how many standard deviation away from the mean? It's 1 standard deviation below the mean, or we denote it as -1. And the reason is because the mean is 600, standard deviation is 50. So 550 is 1 standard deviation below the mean. Therefore, what is 500? In this case, 500 is 2 standard deviations below the mean, or we denote it as -2. So that is how we translate or transform a regular normal distribution to a standard normal distribution, right? The distribution up, when we label as 550, 600, 650, then the unit of this observation is that we are drawing in the milliliter of rain. Is our unit of observations is milliliter of rain. But when we transform the distribution in the standard normal distribution, then 600 is the mean at a 0 standard deviation away from the mean. 550 is 1 standard deviation below the mean, so on and so forth. So when we transform the regular normal distribution into the standard normal distribution, then our unit here is how many standard deviation away from the mean the observation is. So this is an example of how any type of normal distribution can be transformed into the standard normal distribution if we know the mean and the standard deviation. So now if you look up the normal table, right? So again, we want to look up for the area on the left of 500. Or this is the area that beyond z when z is equal to -2. So when we look it up in the appendix A, in the standard normal distribution table, we will see that the area beyond z of z is equal to 2 is 2.28%. And because the normal distribution is symmetric around the mean, so the area on the left of -2 is also 2.28%. In other words, the probability that we succeeds is 2.28%. So what is the formula if we want to standardize any of the observation in terms of z-score and standardize them in terms of standard normal distribution? The formula is that the z-score is going to equal to the observation minus mean divided by standard deviation, or x minus mu divided by sigma. So the intuition for that is that z-score of an observation is the number of standard deviations it falls above or below the mean. Because the mean and standard deviation completely characterize a normal distribution, the z-score is all you need to calculate the probabilities of a normal distribution. So observation above the mean always has positive z-scores, while below the mean is going to have negative z-score, and even observation is equal to the mean, the z-score is 0. So let's use a formula and calculate the z-score of 500 milliliter in the normal distribution with a mean of 600 and standard deviation of 50. So z-score is equal to observation minus mean divided by standard deviation. In this case, 500 minus 600 divided by 50 is equal to -2. So you can see here that the z-score of 500 milliliter when we use the formula is basically the same as the z-score when we intuitively calculated it a few slides ago. When we draw the distribution out, we ask how many 600 is away from the mean, how many standard deviation is 550, and how many standard deviation is 500. So this formula is basically just a formal way to calculate the z-score as using the intuition like we did earlier. So in other words, in this case, 500 is 2 standard deviations below the mean of 600 milliliter. So with a similar kind of mindset, now calculate the probability that cotton will succeed in Burkina Faso. Pause for a moment and think about the answer. So cotton requires between 500 milliliter and 600 milliliter of rain to succeed. So the area that we're going to shade for cotton to succeed is the area between 500 and 600. And we need to find out what this area is in order to know the probability that cotton will succeed. And again, either using the formula or the intuition that we did earlier when we calculate the probability of wheat succeed, we know that the area between 500 and 600 milliliter of rain is the area between an observation that's 2 standard deviation below the mean and the mean. So to find out what this area is, we will look at the standard normal distribution table in Appendix A for the area between mean and z, and in this case, the z-score is equal to 2. And the reason why we look for the z-score is equal to 2 instead of minus 2, because the table doesn't report to us a negative number, the negative z-score. It only reports positive z-score. And seeing the normal distribution is symmetric around the mean, so that's why we, without knowing what the z-score is equal to minus 2, how to read it on the table, we can use the area between mean and z when z is equal to positive 2. And this probability is 0.4772 or 47.72%. So the probability that cotton will succeed is 47.72%. So for this kind of table, you're going to tally out wheat going to succeed with a probability of 2.28%. Cotton is 47.72%. So which crop will you recommend the Burkina Faso government to plant? In this case, you're going to recommend cotton. So this is an example of how we can use probability to directly answer a policy relevant question.